So first point I asked you is what do you mean by average? So please write down heading. Measure of dispersion. Measure of dispersion. What is an average? Average is representative of a data. Now, what are the different types of average? What is the difference? Arithmetic mean. Second is median. Third is mode. How do you calculate the arithmetic mean? Add all the data, x1 plus x2 plus x3 dot 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 xn divided by n. This is, and we denote this by x bar. Median. Middlemost data or middlemost observation when the data is arranged in increasing order. Of magnitude. It can be decreasing order also. Middlemost data, middlemost observation when the data is arranged in increasing or decreasing order of magnitude. What is mode? Observation having
maximum
highest frequency. It's the observation which is repeated maximum number of times. I think this much you have learned in your 10th standard. Is it fine?
Yes, sir.
yes
Now we are coming to what do you mean by measure of dispersion? What does this mean? This is average. What do you mean by measure of dispersion? Why you need a measure of dispersion? I give an example. Two data can have same mean. I give an example. 49, 50, and 51. The arithmetic mean is 49 plus 50 plus 51 upon 3, which is again 50. If you take 1, 50, and 99, the arithmetic mean here is also 50. So by comparing the arithmetic mean, we can't say which is a better data, which is a better representative. So what I meant to say is average is not sufficient to understand the data. We also need the measure of consistency, how much the measure is consistent. And that is called as measure of dispersion. Okay. How much the observations are spread around the average. We also need to know the spreading of data. How much far away are the observations around the average? For example, 49 is only 1 unit away from 50. 51 is also 1 unit away. But just look at this one. This one is 49 at a distance of 49 from the arithmetic mean. Do you agree with this? So which has got a bigger spread? First case or second case?
Second case.
Second case has bigger spread. And how to measure this? How to measure the spreading of data? And that is what we are going to learn in the chapter Measure of Dispersion. Do you follow this? Yes or no?
Yes, sir.
Yes, sir.
Now, one simple method is called as range. If range is too big, range is big. Range is calculated by the highest minus the lowest. For example, highest here is 51, lowest is 49, so the range is 2. For the second case, the range is 99 minus 1, 98. Whose range is more? Second. So this is having a higher spread. That means this is inconsistent data. And this is more consistent data. Everybody understood the meaning of consistent?
Yes, sir.
It's a chance of getting 50 by Sachin Tendulkar. This is Sachin, okay? And this score is. So chance of Sachin Tendulkar getting 50 compared to Kohli is more in a game. I can depend on this person. He is likely to score 50 more often than this person. This person, where one game he may score 90, another game he may become 0. So he is an inconsistent player. He is a consistent player because the range of the first observation is very small compared to the range of the second observation. Did you follow that? Is it clear to everybody? So
yes,
what does the, if I say arithmetic mean is 40, range is 20, arithmetic mean is 39, range is 3. Tell me which is a better performer.
Second one is a better performance because his dispersion is less as compared to first one.
Correct. He is more consistent player because his range is only 3. He is a inconsistent player, which means once he may score, let's say 30, another time he'll score 50, and you will see his average is 40. But the spreading of the data is very high. For this person, it may be 37, 39, and maybe 42. Is it okay? So he is more a consistent player because his range is very small. Everybody understood the idea?
Yes, sir.
Okay. Another way of measuring the data, okay, I'll just give you some questions then. Let me see whether first is only range. Yes. So let's do some problems. Okay, ready?
So I was still writing the previous slide.
Okay. Range you have written?
No.
Calculate the range for this observation. What is the smallest? Lowest?
Lowest is
7.
Lowest is 7, na?
7.
Yes.
Highest?
Highest
45.
45. So calculate range. 45 minus 7.
7. 38.
So range of this observation is 38. Followed, have you understood that?
Yes, sir.
Yes.
Now have a look at next question. Yeah, calculate yourself range of this observation. Which is smallest here?
250.
And what is the highest?
729. 967, sir.
967.
Highest is 967.
717.
Yeah, range is 967 minus 250. So
717.
7.
7.
Now question number 3. You have to just write exercise number and question number 2, question number 3 like that. Following data gives a number of typing mistake done by Radha during a week. Find the range of the data. Which is smallest?
Smallest is 10.
10. 10. And the highest is?
21.
20.
21.
21.
So range is?
11.
21 minus 10 is 11. Okay, next one. Following results are observed by rolling 25 times. A dice 25 times. The range of the following data. Which is the smallest score?
2.
Smallest score?
1, 1.
1.
The score is 1.
Yeah, so you have to look only at the score. You don't have to see how many times you repeated.
Yes.
1 is repeated 4 times. That you don't have to bother.
Hmm.
1, the scores are 1, 2, 3, 4, 5, 6. Tell me which is the smallest score?
1.
1.
1.
Highest
6.
Highest 6.
range? 6 minus 1?
5.
5. Now let last question, 5th one. What do you mean by this? Can you tell me the meaning of this? Suppose imagine the marks of the students have written it. There are 5 students whose marks are from 62 to 64. There are 3 students whose marks are from between 64 and 66 and goes on. Can you tell me what is the range of this observation? What will be the least mark that the student of the class can have?
62.
62. What are the highest marks?
72.
72.
72. So range will be what?
72 minus 62.
72 minus
10.
62. And the answer is
10.
10.
I hope everybody understood.
Yes, sir.
Yeah. Now we'll teach you what is variance and standard deviation. They are more interesting ones. I explain to you. So what is variance? First of all, xi minus x bar is known as what?
Deviation.
Minus
Then squaring of deviation.
it is a deviation.
Yes.
Deviation from where? Deviation
From
from arithmetic.
Arithmetic mean.
When I square it, what will become?
Variance.
Square of the deviation. Square of the deviation from arithmetic mean. Then what did I do after that?
Then
Added
divided
all the
by mean.
deviations. Square of the deviation divided by the number of observation. So it became the arithmetic mean of the square of the deviation. Deviation from, where did I take the deviation? From arithmetic mean.
Arithmetic mean.
And if you take that, and that is what is known as variance. And if you take the square root of variance, it becomes a standard deviation. So I can write now like this. Variance of x is sigma xi minus x bar, the whole square divided by n. And standard deviation is square root of the variance. Next class, I'm going to take the problems on it.